after leaving my laboratory, Liz Blackburn continued working on these ends of the molecules. We had studied them in this protozoan. She then began studying them in yeast, and she joined up with Jack Szostak to study them in yeast. And it was at that point that they realized that the ends of the yeast chromosomes were similar to the ends of these protozoan molecules. And then the realization hit her and other people that these might be more universal. And so eventually, by in situ hybridization, people were able to use probes and probe the chromosomes of different organisms and found that indeed all organisms had this C4A2 sequence or something similar to it. The work that Liz and Jack Szostak and others did established that this simple sequence was the telomere. Now the big problem was, how does the telomere serve to permit the chromosome to replicate its ends? And this was a brilliant insight had by Liz Blackburn and her student Carol Greider after Liz had gone to the University of California. They found that there was an enzyme, a protein, and they found it again in this same protozoan that we had used for the original studies. They found that there was an enzyme which actually extends the ends of the chromosomes and gives a template, an extended template, on which the polymerase molecule can get a foothold on the chromosome, because that polymerase molecule still can only go in one direction. It can't start at the end of the chromosome. So Liz and Carol had the brilliant idea, well, maybe the chromosome just extends itself a little bit for the purpose of this replication, lets the polymerase hop on and move on down the chromosome. And they found that there was an enzyme that did this. It was a brilliant piece of work.